Hi everyone, and today I'm going to be doing the Leaving Certificate 2014 Paper 1. Again, if you've seen any of these videos, I'm going to go through all the questions. I'm going to assume a relatively high level of understanding, so I might skip some of the computations, but I will try to ensure that I make everything as clear as possible, and hopefully it will all be very clear. So again, this is going to be 2014 paper 1, and we'll get started. So the first of these questions is we're given a graph, and we know that f of x is equal to x cubed plus 2x squared minus 5x minus 6. We can see pretty clearly from the graph that it crosses the x-axis at like -3, -1, and 2, and it seems to cross the y-axis around -6. In fact, we're even given these points x, the graph of the cubic function cuts the x-axis at x equals to -3, x equals to -1, x equals to 2, and the y-axis at this. Verified that this can be written as this. So pretty simply, we would just say that it has three roots, or three factors: x plus 3, x plus 1, and x is -2. And the easiest thing really is just to multiply them all out. So doing this part first, we're going to get x squared plus x plus 3x, so it's going to be 4x plus 3, multiplied by x minus 2. So we just did this bit first. And that's going to be x cubed plus, or minus 2x squared, plus 4x squared minus 8x plus 3x minus 6. So that's going to be x cubed, oh, that should be squared, plus 2x squared plus minus 5x minus 6, and that is correct. So that's done. Nothing really more to it than that. Now the second thing we're asked is the graph of function gx is equal to -2 minus 6 intersects the graph at the function f of x above. So we know that it's going to go some way through this like that. Let f of x equal to g of x. So I'll do that first. I'm going to say x cubed plus 2x squared minus 5x minus 6 is equal to -2x minus 6. And solve the resulting equation to find the coordinates of the points where the graph of f of x and g of x intersect. So now that you have these, you should be able to solve them by bringing them across. So -6 is going to turn to +6, so that and that are going to cancel. So you're going to be left with x cubed plus 2x squared, and that's going to become plus 2x, so it's going to be minus 3x. Again, this might be something you're completely used to, but you should have seen this. So it's going to be x squared plus 2x minus 3. So I've gotten this into a quadratic equation. I've taken an x outside. So that's going to be x, x, 3, 1, and I need to get to plus 2. It's going to be minus plus 3 and minus 1. So I'm going to have, and that's equal to 0. So I'm going to have x is equal to 0, x is equal to -1, or x is equal to 1, and x is equal to -3. And then I need to find where and y that they cross. So if I sub them back into this, or I can even sub them back into this. So it's going to be a 0, y is going to equal to, so it's, remember y is going to be equal to g of x. So anywhere where I have that. So for 0, y of 0 is going to be -2 times So y at 0 is going to equal to minus 6. So my point here is going to be 0 and minus 6. And that seems about right because I have a point here. X is equal to 1. So y is equal to minus 2 minus 6. So x is equal to minus 8. And at 1, yeah, that seems about right too. And where x is equal to 3, x is equal to minus 3. Sorry, because that's x plus 3, so 6 is minus 3. So it's going to be minus 2 multiplied by minus 3. So it's going to be plus 6 minus 6, so it's going to be 0. So minus 3, 0. So that seems right as well. Draw the graph of the function g of x on the diagram below. So basically just draw straight through. And we know that it's a straight line because it's, you know, there's no quadratic or cubic function in it. And that's basically it. Important to know that at the top, just to highlight, it does say the cubic function. So you're going to have x cubed. If it was a quadratic function, it would be like x squared, whatever. But that's that question. And it's pretty much done. Not that difficult as long as you kind of figure out what needs to be done and how it needs to be done. All right. So the next one. We have let z of 1 equal to 1 minus 2i. So it's a complex numbers question where I squared is equal to minus 1. So I squared is always equal to minus 1. The complex number z1 is a root of this. Find the other two roots of the equation. So an important thing to know with complex numbers is we should have a complex conjugate. So if I have a graph like this, and my first point is z1 minus 2i. So if I go to out 1 and then minus 2, that's my point 1 minus 2i. Now, I'm also going to have a point here. And the angle between them is going to be the same. So that's alpha, that's going to be alpha. And this is going to be 1 plus 2i. So that's going to be one of my other roots. So I'm going to say z hat is equal to 1 plus 2i. Now it's asking me to find a third root. Now just like if this was x is equal to 1, that would be the root. The factor of it is x plus minus 1. So that's my factor. So just like this, I'm going to say z minus 1 plus 2i is a factor, and z minus 1, and that one is going to be a plus 2i, so it's going to become a minus, so it's going to be a minus 2i. And that's going to be a second factor. So that's going to be factor 1, and this is going to be factor 2. And now that I have that, I basically just multiply them together. So I'll make some space over here. And that's basically what you'll get. And you're going to sub it all down, and you're going to end up with z squared minus 2z plus 5. So that's basically what you get if you work all this out. Remember, anywhere you have I squareds are going to get replaced with a minus 1. So, and that's important to know. So this is the quadratic of these two factors. And now I need to divide this by this in order to get the final root. So it's going to be z squared minus 2z plus 5. And they should sub in pretty easily. So that's going to be 2z cubed. That's going to be minus 4z squared. And multiply 2 by that, it's going to be plus 10z. So it's going to be a minus, that's going to be a plus, and that's going to be a minus. It's going to be minus 3z squared plus 6z minus 15. So that's going to be a minus 3. It's going to be a minus 3z squared plus 6z and minus 15. So basically that all makes sense. That all just goes to 0. And then our other factor is going to be 2z minus 3, which is a root 2z is equal to 3, z is equal to 3 over 2. So there are your three factors. This is a factor, this is a factor, this is a factor, and you're asked to find the roots. So this is your root. That's your root. And this is the other root. So that's all done. All right. Next, let W equal to Z1 Z hat, where Z1 is the conjugate of Z1. So is going to be 1 minus 2i multiplied by, so that's our, W is equal to Z1 multiplied by Z hat 1. So that's 1 minus 1 plus 2i. So it's going to be 1 plus 2i minus 2i, and then that's going to be minus 2i squared, minus 4i squared. And we know that minus i squared, or I squared goes to minus 1, so that's going to go to 4. So W is just going to be equal to 5 and 0i. So our point is going to be here. So plot Z1 and Z hat 1. So we already know that Z hat 1 should be up here, or Z hat 1, yeah, should be up here. So Z hat 1. And our Z1 is down here. Plot them on an R-gram diagram and label each point. Okay, so that's that done. You could join them together if you wanted. Because we know that for the next part, find the measure of the angle Z1 WZ1. So now we're looking for this angle. And the very easy way to do this is this length is going to be 4. This length is going to be 2. So that's going to be tan of your opposite over your adjacent. So this is your angle. So tan alpha is equal to opposite over adjacent. So this is going to be adjacent. So it's going to be 2 over 4, which is going to be a half. So you're basically looking for the tan inverse of a half. And then you're going to need to multiply that by 2. So tan inverse of a half is going to be 26 degrees roughly. And then double that for the 2 alpha, because you're looking for 2 alpha is equal to 52 degrees. So your answer here, that's probably the worst arrow ever, is 52 degrees roughly. So that's that question done. Hopefully that was pretty clear. Yeah. So this is one of these proofs that you probably have come across in your studies. But we're asked here to prove by induction that the sum of the first n natural numbers, 1 plus 2 plus 3 plus blah, 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 n is this, n over n plus 1 over 2. So essentially we're saying that the sum of the numbers that went before are equal to, or the sum of the numbers together, so 1 plus 2 plus 3 should equal 6. And this is the equation that you would get there. So if we did that really quickly, so if we pick a number, so 3, and sub it in, so we get 3 plus 1 over 2. I should get 6 because 1 plus 2 plus 3 is 6. So that's going to be 3 times 4 over 2, which is 12 over 2, which is obviously 6. So the rule is correct. And what it's asking us to do is prove it. So we'll assume that if we have 1 plus 2 plus 3 plus blah, 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 plus n, or we'll say h in this instance, is going to equal to h plus 1 over 2. So if we assume that's correct, we could also assume that h plus 1 over 2, so we assume the value of h is 30. So h plus 1 is going to be 31. So this time, if we want the next value, it would be h plus 2. So if that's what we have, then our equation would be correct. So we can also assume now that if h, or 1 plus 2 plus 3 plus da 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 plus h plus 1 is going to equal to h plus 1 over 2 plus h plus 1. So all I've done here is I've said this is equal to this, and I've added on this. So if we just do like common denominators, that's going to be h over h plus 1 plus 2 over h plus 1 all over 2. And that's going to become h squared plus h plus 2h plus 2 over 2, which is going to be h squared plus 3h plus 2 over 2. That's the worst 2 ever. And then the factors of that is just going to be h plus 1 and h plus 2 over 2. And that is essentially what we had over here, because that is the same as h plus 1 over 2 multiplied by h plus 2. So our left-hand side is equal to our right-hand side. So that's proven. So that's basically what you need to do for that, and just be able to kind of work it down and make it sense for yourself. So hopefully that did make sense. The next bit we're asked to do is to solve this, hence or otherwise prove that the sum of the first n even natural numbers. So this is going to be an arithmetic sequence, because we can see very clearly that 2 plus 4 plus 6. So there's a common denominator, and that denominator is 2. And it looks like an arithmetic sequence. So it's gone 2, 4, 6. We know the next one will be 8, 10, 12, blah, 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 blah. Plus 2n is n squared plus n. So we just need to solve that. So the easiest thing to do would be to go to our maths tables. And in our maths tables, in our sequence and series, we have an arithmetic sequence. Sn is equal to n over 2, 2a plus n minus 1, and d. D being the common denominator, a being your initial value. So our initial value a is 2, and our denominator is 2 also. So subbing in for s of n. So we said our value for s of n is equal to n plus n over 2, 2 times a plus n minus 1 times d. So that is your equation. And our n in this instance, we'll just leave it to n because we're looking for some value of n. So that's just going to be n over 2. 2 times a is going to be 4 plus n minus 1 times d is going to be 2. So that's going to become n over 2. 4 plus 2 times n is 2n minus 2. So that's just going to be n over 2 times 2 plus 2n. Sub that back in. It's going to be 2n plus 2n squared over 2. That that are going to cancel, so you're going to be left with n plus n squared, which is that. So that's it. So you've proved that the sum of the first n even numbers are natural. You can probably do it based on this equation also. I've chosen to use a far simpler method because I knew that this was an arithmetic sequence, and I subbed in the values accordingly. So using the results from A and B above, find the expression for the sum of the first n odd natural numbers in its simplest form. I mean, you could do this in a number of ways. I'm going to do it this way. So I know that the first even numbers, because we said prove the sum of the first even numbers was that, so I did it that way. So this time I'm going to say A. So we're going to look for 1, 3, 5, whatever it is. So our first number again is going to be 1, and our denominator is going to be 2. So Sn is equal to n over 2. 2a is just going to be 2 plus I'm going to have 2n minus 2 because it's going to be n minus 1 and my denominator is still 2. And that very quickly is going to cancel with that. So I'm going to have 2n squared over 2, and my answer is n squared. So using the values, find the expression for the sum of the first n odd number in its simplest form, and that's your answer. Yeah, so that's that. Hopefully that was clear. The next question is a differentiation question. Yeah, and you just kind of need to do that accordingly. And it's asked to with respect to x from first principles. So with first principles, we're always going to let f of x, and it's going to be plus h minus f of x divided by h. So we basically just sub in those values. So we have 2x plus h to be squared minus 3x plus h. We're going to have a long equation, minus 6. I'm going to put that in a bracket. And I'm going to say minus 2x squared minus 3x minus 6 all over h. So I better do this a little bit carefully. So x plus h squared is going to be x squared plus 2xh plus h squared. So that's going to be x squared plus 4xh plus 2h squared minus 3x minus 3h minus 6. I better put that in a bracket in case I missed the minus. Minus 2x squared plus 3x plus 6. So loads should cancel. And just one important thing, I know that my answer is going to be 4x minus 3. So the f of x, f dash x of this is equal to this. So that's the answer I need to get. I just need to do it via first principles. So that is going to cancel with that. So that's 2 of them gone. That is going to cancel with that. So that's another 2 gone. That is going to cancel with that. So I need 4x minus 3. Yeah, so now I have this, but if I divide everything by h, I'm going to be left with 4x plus 2h minus 3. But I need to find out the limit as h becomes 0. So that's going to be 4x minus 3. So that's done. So that's doing it by first principles. Yeah, there's kind of not an awful lot more to it. That's how you do them. The next bit is to, I presume, do differentiation also. So we're told let f of x equal to 2x divided by x plus 2. X does not equal minus 2. X is a real number. Find the coordinates of the points at which the slope of the tangent to the curve y f of x is equal to a quarter. So if we should know from our books and from our learning that dy dx is the gradient. So it's the gradient, basically the rate of change of a function. But dy dx is equal to m. That's just an important point. And this is a division. And we should know from our maths tables again, if we go to the calculus part. Now my maths tables might look a tiny bit different than what you're used to, but they will be the same. So you'll have y is equal to the quotient rule, u over v. So it's dy dx is v du dx minus u dv dx over v squared. So it's, I need to use the quotient rule. So it's v du dx minus u dv dx all over v squared. And I'll just make sure that's correct. Yep. So this is going to be my u, and this is going to be my v. So v is x plus 2, and du dx is just going to be 2. Minus u is minus 2x, and the v dx is just going to be 1, so I can leave that. All over v squared, so that's x plus 2 to v squared. And that's going to be 2x plus 4 minus 2x. That and that is going to cancel. So it's going to be 4 over x plus 2 to v squared. Now, we're told that the tangent is going to be a quarter. So we're told that dy dx, so find the coordinates of the point at which the slope of the tangent is equal to a quarter. So we basically just let this equal to a quarter. And that's going to be, because this, as I said, dy dx is equal to m. So if we let that equal to a quarter, we're going to get 16 is equal to x plus 2 to b squared, which itself is going to be 16 is equal to x squared plus 4x plus 4. That's going to be x squared plus 4x minus 12, which is going to be x. Again, I'm just doing quadratics, so that's going to be x plus 6 and x minus 2. So x is equal to minus 6 and x is equal to 2. So now I have the x coordinates on that point. I know that my graph, or my y function, so remember f of x is equal to y. So if we had a graph like this, you're basically anywhere you're functioning in for the y value. So I have minus 6, so 2 times minus 6 over minus 6 plus 2. That's going to be minus 4, or hold on, no, sorry. That's 2, yes, that's going to be minus 12 divided by minus 4. So that's going to be 3. So my point here is minus 6, 3. And my other point is x is equal to 2. So y is equal to 2 times 2 over 2 plus 2. So that's going to be 4 over 4. So that's going to be 1. So my other point is 2 and 1. And that's that. So important things to know, dy dx is equal to your slope. And you solve the quotient rule, and then at that point you found dy dx. It tells you what the tangent to the curve is, so you let it equal to that. You sub in your values, and again, f of x will always be y. Okay, hopefully that was clear. Next one, yeah. So there's a few different ways you can do these. I'm going to tell you a little cheat way to do this one. It's pretty simple. So you're looking for the integral of this. So first of all, the cos, go back to my maths tables. So I'm looking for integration. Cos is just going to be plus sign. So you can take the 5 outside. So it's so cos 3x dx. And basically with these, you can, the easiest way to do it when you have something like this, and I told it in another video, if it was just f of x would be equal to the integral of f of x dx. But if you have f, say ax plus b, it's going to be 1 over a, the integral of f ax plus b dx. So in that regard, we're going to take a third outside it. Cosine or sine, this stays the same. And that's your answer. So your answer is 5 over 3 sine 3x plus c. So always remember to bring your constant of integration across. That's that, pretty easy enough. The next thing we're told, the slope of the tangent to a curve y is equal. By the way, just on that one, obviously it's where you have a multiplying function of x. So you could have like sine 2 theta over 365 x. Again, you do the same thing. It's just an easier way for integration by substitution. It just makes it a lot easier. So the next one we're looking at is the slope of the tangent to a curve y is equal to f of x. At each point, xy is 2x minus 2. And the curve cuts the x-axis at minus 2 and 0. So what we know about this is the slope of the tangent to the curve is this. So we know dy dx is equal to 2x minus 2. So if we want to go back a level, so remember differentiation is one way, but integration is the opposite. So if you had like in a car is driving down the road. So the distance, if you want to find the velocity, you differentiate to find the velocity with respect to so it's the rate of change of distance with respect to time. And that becomes your velocity. If you want to find the integration, if you have the velocity, you can work backwards to find the distance. In this instance, we have the slope, so we need to kind of work backwards to get f of x. So f of x in this instance is going to be y is equal to the integral of 2x minus 2, and that's going to be 2x squared over 2 minus 2x plus c. So that's going to cancel. So you're going to be left with x squared minus 2x plus c. So now we know that the curve cuts the x-axis at minus 2 and 0. So we could say that f at minus 2 is equal to x squared minus, it's not going to be x squared, it's going to be minus 2 squared, because we're subbing it back into this equation, remember. So it's minus 2 to b squared minus 2x plus c. So that's going to be minus 2 plus c. So that's going to give me, and that's all going to be 0, because we know that at that point, y is equal to 0. So we're trying to find the function of minus 2 here, because we're basically looking for c. So we have, that's going to be minus 2 to b squared, so that's going to be 4. That's going to be plus 4 plus c is equal to 0. And remember, just as y is equal to 0, we can say that because we know that y is equal to 0 at that point. So c is going to be equal to minus 8. So our equation, working back, is going to be y is equal to f of x which is equal to x squared minus 2x minus 8, and that's your answer. That's all there is to it. The next one, find the average value of f over the integral of the interval 0 x 0 is x is greater than or equal to 0, x is less than or equal to 3. So when you're looking for something like this, you're going to have some value over here, so that's going to be 0. You're going to go up to 3. You're going to have some curve working its way along. I mean, it could be very differently shaped than this, but you know it's going from 0 to 3, and you're essentially looking for the average value of that. So for this, you're essentially looking for the area under the curve, the average value of the area under the curve, and in that instance, it's going to be 1 over b minus a, the integral of the limit b to a, f of x dx. You just need to really know this equation, and once you know the equation, you just basically sub it back in. You know b is equal to 3, you know a is equal to 0, so working that back, it's going to be 1 over 3 minus 0, and that's going to be 3, that's going to be 0, and you're looking for x squared minus 2x minus 8 dx, because you just basically sub back in your value. And that's very quickly just going to be 1 over 3. That's going to be x cubed over 3 minus 2x squared over 2 minus 8x. And again, I'm assuming you know how to integrate pretty well, so I'm not going through, but obviously it would be, if you didn't know how to do this, you would just basically work it out via like this. So xn, so x squared is x squared plus 1 is x3 over n is 2, and that instance plus 1, so x squared or x cubed over 3 is your answer. That all subs down to basically minus 8, and that is your answer. I haven't done them in, but basically you'd sub in 3 minus, and you can leave the other side equal to 0 completely, because everything, there's x's and everything, so it's all going to go. Your answer is going to be minus 8. So that is done, and that is your answer. Hopefully this question is question 6, and it starts off by saying the nth term of a sequence Tn is equal to Ln A of n, where A is greater than 0 and A, we're told, is a constant. So the first thing we're told is show T1, T2, and T3 are in an arithmetic sequence. So an arithmetic sequence would be something like 3 plus 7, oh, sorry, not 3 plus, it'd be like 3, 7, 11, 15, where you essentially have a number, A is equal to 3, so the first number in the sequence, and then every number thereafter is separated by a constant. So between each of these, there is a constant of 4. So your common difference, D, is equal to 4. So that's a arithmetic sequence. So now you have to show that these 3 are in an arithmetic sequence. Now we know that Tn is equal to Ln An. So we have that. And this is where it's really important to know your log rules. These kind of things come up quite a lot, and being able to understand what needs to be done with your logs is important. So Ln, of course, is just log to the base 10. So if this was log x a to the k, we'll just say as it would be normally. When we turn that back, we put the k, so we'll put the brackets outside it, and essentially you end up with k log to the base x of a, and that's how it gets rephrased. So based on that, this is going to be the same as a ln, sorry, not a, n ln of a. So in that regard, T1 is going to be 1 ln of a. T2 is going to be 2 ln of A, and T3 is going to be 3 ln of A. And we clearly have a difference of ln of A between each one. Show that they're an arithmetic sequence. They're an arithmetic sequence, yes, because they have a common denominator, a common difference. Of 1, or of ln of A, or 1 ln of A, so an arithmetic sequence. So that's correct. Prove the sequence is arithmetic. Well, we've kind of done that, but I mean, you could do it. You could also say T3 minus T2 is equal to 1 ln of A. T2 minus T1 is equal to 1 ln of A. And the fact that they have a common difference of 1 ln of A proves that. Is there anything else? Nope, that's it. Find the value of A for which T1, T2, T3 plus all the way up to this is equal to this. Now, earlier on, we obviously looked at an equation. I think it was on question 2. My h plus 1 over 2. So we could use that if we wanted, but I'm going to use the one straight out of the maths tables. And out of the maths tables, we have Sn is equal to n over 2, 2a plus n minus 1 over d. So it's a summative arithmetic sequence, so I'll just use that. So I'll write that over here. So it's n over 2 times 2a plus n minus 1 d. And n is equal to 100 because I have 100 terms. D is going to be equal to 1 ln of A. And T1, which is A, is going to be equal to 1 ln of A. So subbing those back in, you get 100 over 2. Times 2 times A is going to be 2 ln of A. Plus, that's going to be 99 ln of A. And we're told that that's equal to 1. So that's basically what we have now. So this just goes to 50. This is going to be 101. Ln of A. And that's going to be 5,050 ln of A. And that's obviously just going to be 2. So ln of A is going to be equal to 2. And here we need to know what to do with our logs again. So this is going to be essentially e to the ln of A is equal to e2. That is just going to become 1. So it's going to be A is equal to E squared. A is equal to 0.389. So next part is verify for all values of A that T1, T2, T3, all the way up to T10 plus 100 times D is equal to T11 all the way up to T20. So again, you would do the sum, the arithmetic sum, and make sure that the two were the same. So the first one is going to be this, A for this is going to be 1 ln of A. The difference, the common difference, is going to be 1 ln of A. And yeah, that's what you need for that. And your terms, n is going to be equal to 10. And this one, your A is going to be 11 ln of A. Your D is going to be 1 ln of A. And your n is also going to be equal to 10. So you're essentially just going to end up with 2 formulas. So we'll do this side first. So that's 10 over 2. And it's going to be 2 ln of A plus 9 times ln of a plus 100 ln of a. And that should equal, so this side then is going to be 10 over 2, and it's going to be 22 ln of a plus, and it's also going to be 9 ln of a on this side. So that's going to be 5 times 11 ln of a plus 100 ln of a, which will be 55 ln of a plus 100. So that's going to be 155 ln of a, and I should end up with that over here. So I'm going to get 10 over 2 and 31 ln of a. That's going to be 5 times 31. And that is correct, because 5 times 31 is 155 ln of a. So that is correct. So verified for all instances of a. So if I put in any value of a, 1, 2, 3, 4, it wouldn't make any difference. These would be the same. Where D is the common difference of the sequence, that's correct. So you have proved that. So that one's correct. Okay, next one. These 3 natural numbers a, b, c such that a squared plus b squared plus c squared are called a Pythagorean triple. So we have 3 natural numbers. Natural numbers are going to be 1, 2, 3, 4, 5, 6, not minus ones. Basically, you have to be in the plus line, and they have to be whole numbers. Okay, so in terms of just knowing something important, a Pythagorean triple is something like 3 squared plus 4 squared is equal to 5 squared. So you have 3 natural numbers. So basically just 9 plus 16 is equal to 25. Another example of them is 5 plus 12 squared is equal to 13 squared. So that's 25 plus 144 is equal to 169. So they're just 2 examples of a Pythagorean triple. All right, so let a equal to 2n plus 1, all right? B is equal to 2n squared plus 2n, and C is equal to 2n squared plus 2n plus 1. Pick one natural number and verify that the corresponding values of a, b, and c form a Pythagorean triple. Okay, so I'll just pick 1 because it's going to be easy. So a is going to be 2, 1 plus 1. That's going to be equal to 3. B is going to be equal to 2 times 1 squared plus 2 times 1. That's going to be 4. We're looking nice and neat now. 2n squared, so C is equal to 2, 1 to be squared, plus 2 times 1 plus 1, and that's going to be 5. And as I said, that is a Pythagorean triple, so that kind of worked out nicely. Yeah, so that's pick one natural number, and that's a squared plus b squared plus c squared is equal to c squared. These are all natural numbers, so that's an element of the, that's an element, I'll make that 4 more obvious, and that's an element of a natural number, so this all makes sense. All right, prove that prove that a equals 2n plus 1, b is equal to 2n squared plus 2, and c is equal to this, where n will always form a Pythagorean triple. Okay, so we want to form that it will always happen. So in a Pythagorean triple, we have this equation. A squared plus b squared is equal to c squared. So we'll basically just write that out and see where we get to. So a squared is going to be, I'll do them all over here, just so I don't run out of space completely. So it's going to be 2n plus 1 to be squared. So that's going to be 4n squared plus 4n plus 1. B squared is going to be 2n squared plus 2n to be squared. So that's going to be equal to 4n to the 4 plus 2n squared, so it's going to be 4n cubed plus 4n cubed plus 4n squared. So that's going to equal to 4n 4 plus 8n cubed plus 4n squared. And then c squared is going to be 2n squared by 2n squared plus 2n plus 1 plus 2n by 2n squared plus 2n plus 1, and then plus 2n squared plus 2n plus 1. So that's going to be 4n to the power of 4 plus 4n, not m, n cubed plus 2n squared plus 4n cubed plus 4n squared plus 2n squared plus 2n plus 1. So this is going to be 4n to the power of 4. This match is going to be plus 8n cubed. This, and this is going to be plus 8n squared. This and this is going to be plus 4n plus 1. So that's c squared. And a squared plus b squared, so that's 4n squared plus 4n plus 1 plus 4n to the 4 plus 8n to the 3 plus 4n squared is going to be a squared plus b squared is equal to 4n to the 4 plus 8n cubed plus this and this plus 8n squared, this plus 4n plus 1. So both your sides match, so you are 100% correct. All right, nothing else to it really. Yeah, just an important thing to know, the Pythagorean triple, it can come up. Again, I would advise you to study as many maths books as you can to make sure that you understand all these terms, whether it be, a parabola, whether it's a Pythagorean triple. These things kind of come up and they can throw you if you're not really sure of what's being asked. So the next thing is ADEC is a triangle. So we have a triangle, A to C, E to D, or ADEC as it says here. And we know that A to C is 7 meters. That's fine. And AD is 2 meters as shown. So this is 2 meters. So that's fine. So this is also 2 meters. Yeah. Now we know that that's a right angle. That's a right angle. That's a right angle. And that's a right angle. Because it's a rectangle, so all the angles must be 90 degrees. B is a point on AC such that AB is equal to 5. So that's 5. That's fine. P is a point on DE such that DP is equal to X meters. So the first thing I'm going to do is I'm going to draw this line, because I know that I'm first going to be looking for PA squared. So I'm looking for, so that's a right angle triangle. Next I'm looking for is PB. So I need to know this. And I need to know PC squared. So PA squared is going to be equal to AD squared plus DP squared. And AD squared is 2 squared plus X squared. So I know that the first one is PA squared is equal to this. Next one I want, PB. PB is going to be a little bit more difficult to find. So I'll just do PC first, because again, that's a right angle triangle. So PC is going to be so this is going to be x, and this we know is 7. So this is going to be 7 minus x. So PC squared is going to equal to 2 squared plus 7 minus x to b squared. Now, if I know that this is 5 meters, so if I draw a line straight down here, this is now going to be a right angle. I know that this length is going to be 5 meters minus x. So this is 5 minus x. Because if this length was 5, and if this length was x, this is 5 minus x. And I know this is 2, so PB squared is going to be equal to 5 minus, or 2 squared, plus 5 minus x to b squared. And what have I been asked? Show that f of x, and I don't know, f of x is equal to this. So I basically need to say that if I put these 3 equations in, that they would equal to this. So I'll just do that. So f of x should be equal to 2 squared plus x squared plus pb squared, so it's 2 squared, plus 5 minus x to b squared, plus pc squared, which is 2 squared, plus 7 minus x to b squared. So that's going to be 4 plus x squared plus 4 plus 25 minus 10x plus x squared plus 4 plus 49 minus 14x plus x squared. So I got 1, 2, 3. So I'm starting to look pretty nice because I know that I'm looking for this, and this is 3x squared. I hope I didn't make a mistake in the calculations anywhere. So I've now minus 24, so I need this and this. That's good because I have minus, and that's minus 24x. And then I finally need 86, so I'm kind of hoping that these all add up. So 49 and 25 is 64. It's not, it's 74. So that's 74 plus 4, 78. So 1, 2, 3 done, 78. And 78 and 8 is going to be 86. They're all pluses, ding, 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 ding. Yeah, so I'm at plus 86. And that is correct. Yep. So yeah, so I was basically given this equation. I was told it was equal to this. I used my block and figured out kind of what I had and worked everything out accordingly. The function f of x has a minimum value of x is equal to k. Find the value of k and find the minimum value of f of x. So when we're looking for minimum values, we always need to think about differentiation. Because we will find the minimum value where d squared y dx squared. And so if we had a graph like this, we will find the maximum value, but we will find the minimum value around here, and that would be d squared. And that's greater than 0. So you have to find f dash of x. That's going to be 6x squared minus 24. And the second derivative of it is going to be f dash x. And that's going to be 6. And that is greater than 0. So that is our minimum. So with that in mind, I go back to my second differential, which is this one. And I sub in a value for k. and I sub in a value for k for f of x. So I'm going to say k is equal to 6k minus 24 is equal to 0. So 6k is equal to 24. K is equal to 4. And then it said find the value of k and the minimum value of f of x. So I found my minimum value of k, and then I just basically sub it back into this. So it's going to be if x was equal to, so that's, remember, that's going to be equal to x. So it's going to be 3 times 4 to be squared minus 24 times 4 plus 86, and that is going to become 38. So 38 is your minimum value of f of x. I hope that's clear. Yep. Moving swiftly along to the last 2 questions. All right. In 2011, a new footbridge was opened at Mizenhead, the most southwesterly point of Ireland. The arch of the bridge is in the shape of a parabola as shown. The length of the span of the arch AB is 48 meters. So with this kind of question, we're usually going to be looking at integration. I know that from the second half because it's basically asking us to find the area under the curve. But generally, for these kind of parabola questions, you're going to be looking for the area under the curve. So they do end up being some sort of an integration question. So just being able to identify them and knowing what to do with them appropriately is going to be obviously important. So the first bit that we're told, using the coordinates, okay, so what we're told. So we're told in 2011, a new footbridge was opened. The arch of the bridge is in the shape of parabola. The length of the span is 48 meters. So we have this point, we have this point, and there seems to be some, there's a walk bridge, and it seems to be 5 meters above the ground. Using the coordinate plane, A is 0, 0, and B is 48, the equation of the parabola is equal to this. Find the coordinates of C. So what he's basically asking us here is find the highest point of this parabola. And if we want to do something like that, we will find that by finding where the turning point is going to be dy dx is equal to 0. Now I said integration a few seconds ago because that's the area under the curve, but we also have to do differentiation. And we know that we need to do differentiation here because we're looking for the highest point. Because it says find the coordinates of C, the highest point of the arch, and we're going to find the highest point by differentiating it and letting dy dx equal to 0 and subbing in accordingly. So we will differentiate. So dy dx is equal to minus 0.026 x plus 0.624. And remember, I'm going to let that equal to 0. So I'll do that. 0.026x is equal to minus 0.624 because I've let that equal to 0. And that should it should divide very easily. It doesn't. So that's going to be, actually it's going to be 24. So x is going to be equal to 24. Now, that gives me my x value. So I now need to find my y value. And I sub this x value back in. So I found the point here on the x axis. And I now need to find the y value. So we know that y is equal to minus 0.013 24 to the squared plus 0.624 times 24. And working that out, we're going to get a value of 7.488 meters. So our point is going to be 24 and 7.488. Again, very important to know that if you're looking for this, you're looking for the highest point, you're going to need to find that turning point. The turning point dy dx is going to be 0. And you basically just need to solve them accordingly. So once you sub in for that, you get dy dx equals 0. You're going to get a value for x. And now that you've found a value for x, you sub that back into your y equation. And you find your value for y. If it would said f of x is equal to this, remember that that's essentially saying y is equal to All right. The perpendicular distance between the walking deck, DE, and AB is 5. Find the coordinates of D and E. Give your answers correct to one place of decimal. So we know that this time our value of y is going to be equal to 5 because we know that this is 5. So rather than saying y is equal to 0, this time we're going to say 5 is equal to, and this is going to give us our x coordinates. So minus 0.013 x squared plus 0.624 x, which is the same as minus 0.013 x squared plus 0.624 x minus 5. So I'm going to change that to a plus, going to change that to a minus, going to change that to a plus, and let the whole thing equal to 0. So this is obviously very difficult to work out. So the obvious thing to do is go minus b plus or minus the square root of b squared minus 4ac all over 2a. And that's going to end up giving you values of x of 10 and another value of 38. And then your point is going to be 10, 5, because our y value again is 5, and a value of 38 and 5, because again our point is 5. And that's going to be that part. The next one, using integration, find the area of the shaded region ABED shown in the diagram below. So in order to find the shaded area, you could break this into a rectangle, kind of do it that way. But the easiest thing, I think, is to find the full area and then take it away from the smaller area. And the area for finding this is going to be area is equal to the integral of the limits b to a all over f of x dx. So our earlier equation when we were doing them, that was to find the average height. This is to find the area under the curve. We know our values a, b. We also know these ones, so it should be pretty easy to work out. So it's going to be 48, 0. And f of x dx, it's going to be minus 0.013 x squared plus 0.624 x dx. So that is going to become minus 0.013 x cubed over 3 plus 0.624 x squared over 2, 48 and 0. So the area of that is going to end up being 239. So you just sub in the values for x, close enough to that, meter squared. And the other one then is essentially going to be pretty much the same equation, but this time we need to bring it down by 5. So it's going to be the limit of 10 and 38 minus 0.013 x squared plus 0.624 x minus 5. That's going to end up with essentially the same thing here. So you get minus 0.013 x cubed over 3 plus 0.624 x squared over 2 minus 5x, the limits of 38 and 10. So you have to sub those back in, and you're going to get essentially 45.8 for this, or 9. And you end up with it's asking you to give your answer to the clearest whole number. So you take this away from this, and you end up with a value of around 194 meters squared. So that's the easiest way to do that question. It's important to know this equation. Yeah, and once you know that equation, it should be relatively simple. And just something to make sure you're aware of, you're going to have to take away 5 because your value is coming down 5 levels of x. Write the equation of the parabola in the form y minus k p x minus h c squared. So we need to write our equation from the parabola, which is this, in this sort of a format. So if I had y, I'm just going to write it down again. So sorry, 0 x squared plus 0.624. So we need to get that in this format. So 0.013 actually divides into this 48 times, and we can, it just does. So it's going to go in 48 times. Because half of it went in 24 times, so double it's going to go in 40 times. So it's going to be 0.013 x squared plus 48x. So now we have something in this format. Getting close, at least. Now this is a completing the squares part. So when you're completing the squares, it's important to know that, I'll just write that equation in a different color. So it's going to be ax squared plus bx plus c is going to be the same as a x plus b over 2a all to be squared plus q. And q is essentially c minus b squared over 4a. So you use this equation when you're not really sure on how to break these down, and this is an example of completing the squares. So it's going to be 1 over x, because I'm just looking at this, plus b is 48, all over 2 to be squared, plus, and now c is 0, that's going to be 48 squared, so that's going to be 576. All over 4a, 4 times 1, and that's going to be a minus. So that's going to be 48 squared over 4, and that ends up being 576. And it's going to be a minus. And that ends up being that whole bit here, so it goes to x squared plus 48x plus 576 minus 576. So that's us completing that square. And you end up with, so minus 0.013, all multiplied by this bit, x squared plus 48x. That's a minus actually, right? So this bit is going to be a minus. I apologize for that, because it's minus this, and now that to get that a plus, you need to have a minus. So it's going to be this. And yeah, so that's correct. So we're going to have minus 48x. So it's going to be plus 576 minus 576. And this bit is going to become x minus 24 all to be squared. Multiplied by, or sorry, minus and this bit minus 0.013 is going to become very small. It's going to become 7.488, and it's going to become a plus, so 7.488, and you want to leave that other minus 0.013 in front. And y is equal to this. So I wanted to get it in this form, so I'm going to just bring that across. So it's y minus k, so it's going to be 7.488 is equal to, and that's just going to be that. So it's minus 0.013. Move that for a second. X minus 24 all to be squared, and when we have that in it, so we have it in the correct format. So that is your answer. I suppose the main thing to know is the completing the squares element. That's obviously very important. A little bit of a tricky one, I suppose. But yeah, and kind of that's what you need to do for that part. The final one then says, using what you've learned in part D above, write down or otherwise write down the equation of a parabola for which the coefficient x squared is minus 2 and the coordinates of the maximum point are 3 and minus 4. So it says what we learned above, right? So this is what we learned above. Now, we know from originally that our highest point, or the middle point, was 24, and our highest point was 7.488. So if the highest point of this is 3 minus 4, it's essentially asking us to sub in these values. So I will. So instead of my height being, my height here was 7.488. Here I have y, and it's going to be minus, it's going to be plus 4. Oh no. It's going to be, the coefficient is going to be minus 2, and you know that. So that you work that out, it'll be minus 0.013 x squared. And you're told that this is the coefficient is minus 2, so it's going to be minus 2 x minus 3 to be squared. Write down an equation of the parabola, and that's it. Yeah, I mean, you basically just need to be on the ball and notice that this subs back into your original equation where your height was 24, or your midpoint was 24 and your height was 7.488, because you have those values in your new equation. And because you have those values, you basically sub them in for your new maximum point and your new coefficient. And that's, as long as you figure out what needs to be done, it should be pretty easy. Yeah, but again, it's a case of knowing what needs to be done and figuring it out accordingly. And the last question then is Kieran is preparing food for his baby and must use cold boiled water. The equation the equation y is equal to AEK describes how the boiled water cools. So we know that he's preparing food for his baby and must use cooled boiled water. So the water is going from 100 down to cooled water. I think it's going to be 100. So the equation y is equal to AEKT describes how the boiled water is cooling. So this explains how that water is cooling from one temperature to the next. In this equation, T is the time in minutes from when the water is boiled. Okay, so T is just minutes. Y is the difference between the water temperature and the room temperature at T measured in degrees Celsius. So we know that Y is equal to the temperature of the water minus the room temperature. or the room temperature of the water, measured in degrees Celsius. A and K are constants. So the water temperature of the water when it boils is 100 degrees, and room temperature is a constant 23 degrees. So the water is trying to go from 100 degrees to 23 degrees at all points. So write down the value of the temperature difference Y when the water boils, and find down the value of A. So the temperature when it boils is 100, and the room temperature is 23. So Y is equal to that. So Y is equal to 77. So that's the difference in temperature. And then you have to find the value of A. So we know that Y is 77, and it has to equal A, E, K, T. So we know that this is when the water gets to 100 degrees. So when the water is at 100 degrees, is at time 0, right? So it's at 100 degrees at T is equal to 0. Now, once the heat is taken off, the temperature is obviously going to drop. So at the time when it's 0, the water is equal to 100. And then from that point on, the water is going to drop in temperature. So if you had a graph, it's going to be T is equal to 100. Or T is equal to 0, the temperature is going to be 100, and it's going to drop in that kind of way. So we can let T equal to 0 here. So that is going to go to 0. So then it's going to be A, E, 0. And E to the 0 is going to be 1. So 77 is going to be equal to A. And it's a constant, so there's no SI unit. That's your answer. All right then. After 5 minutes, the temperature of the water is 88 degrees Celsius. So now we know that the temperature of the water is 88 degrees. So Y is going to be 88 minus 23, because it's the difference in temperature between room temperature, so water temp, the boiled water temperature and the room temperature, or as the boiled water decreases. So that value is going to be 65. And we know that we're looking for this at T is equal to 5. So if we say, write down the equation again, so we have 65 is equal to 77 E K to the 5. So 60, well, first of all, we're going to divide 65 by 77 is equal to E K 5. So you're going to say ln of 65 over 77 is equal to the ln of EK5. And this again becomes 1. So you're left with ln of 65 over 77 is equal to K5. And your value for K then is going to be minus 0.0339. Yeah, so your ln value is going to give you a minus, and that's going to be your value. Okay, Kieran prepares the food for the baby when the water has cooled to 50. So just to get back, it's important, very important for these type of questions, especially to read very clearly what's being asked. So often people can kind of, start writing down stuff, I suppose to get some, attempt marks and kind of get lost in what's really being asked. So it's very important to take your time, take a breath, and read what's being asked, and then, read it again and again and again. And then it should, if you write it down very slowly, start to make a lot of sense. Okay, so Kieran, because as you can see, the question is actually pretty easy at every point once we get a grasp as to what's really being asked. So Kieran prepares the food for the baby when the food has cooled to 50 degrees. So now Y is equal to 50 minus 23. I know I just kind of broke myself by saying don't just write things down too fast, but yeah, I mean, you need to read things very clearly. How long does it take, correct to the nearest minute, for the water to cool to this temperature? So we have a new temperature. It's at 50 degrees. So now we're going to go to 27. So now y is going to be equal to 27. Now, if we go back to this equation, we know A, we know K, E is a constant. So what we're looking for is T. So y is going to be 27 is equal to A, which is 77. E, K is 5. Oh, sorry. K is 5 times T. So again, it's going to be 27 divided by 77, which is almost the exact same as the last question, to be honest. E over 5T. Again, you're going to let that equal to ln. Right, equal to ln 27 over 77 is equal to E ln E of 5T. That's going to go to 1. It's, again, so crucial that you know these log exponential rules. Again, they come up so often. So you're going to have T is equal to 30.9. And it says correct to the nearest minute. So T is going to be equal to 31 minutes. Okay, so, and this is 60 marks, this question. This is like, you know, 2 of the earlier questions, and we've done half of it. And it really hasn't been difficult at any point as long as we figured out the first bit, what was really being asked and how to work that out. Using your values for A and K, sketch the curve Y, A, E, K, T for along. So here we're just going to say so we know at time 0, T is equal to 0, that the value is 77, because we've already solved that here. So that's going to be something around here. At T1, I'll just do T1. So it's going to be T1, I'm going to let equal to 10, because it's my 10. So it's going to be A, E, K, T, or 77. E, K I know is minus 0.0339, and my T is going to be 10. So that value is going to come to 55. T20 or T20 is going to equal to 39. T30 is going to equal to 28. T40 is going to be 20. And you just basically sub them in the exact same way, just changing the value of T as you go along. T50 is going to be equal to 14. And I'm going to go from to 100. So T60 is going to be 10. 70 is going to be 7. It's going to be 5. It's going to be 4. And that's going to be 3. So it's meaning the difference in temperature between the water and room temperature. So it's 50. So it's 55 for the next one. It's 39 for this one. So around here. It's going to be 28 for this. So around here. And it's going to be 20. It's going to be 14. Oh, sorry. 20. It's going to be 14, which is around here. T60 is 10. Around here, 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 and here. So then just draw in some sort of graph like that. So that's that. So using your values A and sketch the curve. So that's the curve A, E, K, T, F of X. And then it says, on the same diagram, sketch a curve GT, A, EMT, showing that the water cooling at a faster rate. So if you aren't sure, I suppose the easiest thing to do is you're trying to find it cooling at a faster rate. So you can imagine that you're looking for the curve to go something like this. Whereas if you want it to cool faster, it obviously has to go in that sort of format. And in order to do that, what you need to do is you need to change the value of K for M, because it says everything else is staying the same. A is a constant, E is always going to be the exponential, T is going to be relevant to that particular time. So what you need to do, and you could do this two ways. You could put in minus 0.3 and minus 0.4 and see what answers you get. And I know that from putting in minus 0.4, that my graph is going to go this way. So that's at A, E, M, T, where M is some value equal to minus 0.04. And yeah, that's kind of what you do. If you aren't sure, again, just put it into your calculator a few times and make sure you get the right answer. It says suggest one possible answer for M. So I've done that, and sketch the sketch you have drawn, for the sketch you have drawn, and give a reason for your value. So possibly M is equal to minus 0.04, and give a reason for your choice. And you could say where M is less than K, the cool down is faster. Cool down faster. So then we're just asked for one final part. So I'm just going to hide this. And we need to find the rate of change of the function f of t. So at this point, it's important to know this. I'm sure you do, but in case you don't, dy dx is the rate of change of the function. But dy squared d squared x is equal to the rate of change of the gradient. So that's an important thing to know. So we need to find the rate of change of the function. So y is equal to a e k t. So y is equal to a e k t. And in order to find the differentiation of that, we go to our tables, to the calculus part. Sorry, wrong way. And we go to the e. So if we differentiate e, it's going to be EAX, so AEAX, which effectively means dy dx is going to be AK. So I'm respect to time, so it's going to be t. So it's AEKE KT. So that's that. And then you need to find the rate of that change after 1 minute and after 10 minutes. Now, A is still going to be 77. K is still going to be minus 0.0339. And we just need to find it at 1 minute and 10 minutes. So at t is equal to 1, it's going to be 77 times minus 0.0339. E minus 0.0339 times 1, and at t is going to be the exact same thing at times 10 seconds, or times 10 minutes. So I'll write that in altogether, just in case anyone is not sure what I'm talking about. The answer for that, very quickly, is going to be minus 2.52. So the rate of change at this is minus 2.52, and the rate of change at this is minus 1.84. So the rate of change is, I suppose, increasing over time. because it's going from a lower value to a higher value. And it says, show that the rate of change will always increase over time. So we need to find the d squared y, because we need to find the rate of change of that gradient. So our function is just going to be d squared y dt squared is going to be a k times k e k t. So that value is 0.0855 e to the minus 0.0339 t. Our curve is like this, so it's convex. And because dy dx is increasing, so this is going to be greater than 0, and we can say dy dt is increasing. Hence, so the gradient is getting bigger as that approaches, as that gets. The gradient is getting bigger, the rate of change of the gradient is getting bigger as the time increases. So you can say that dy dt is increasing over time. And that's it. Hopefully you found all this very useful. Any questions, feel free to leave them in the comments. Please join the Facebook page at More Learning Limited, where I will be publishing more exam paper answers as we move forward. Thank you very much for your time.